can distinguish the lasers with the normal light? Anyone? Anyone? Any idea? Just think for a while. No? No idea? Okay. Just see here now, slides. So what is the difference between the incandescent light and the laser? Anybody tell me what this light, how the light rays will come from the bulb? Anyone? What is the properties of the incandescent light? This is the normal bulb, right? Everyone can see in our old homes. Now we can see the all LEDs. Normally we can see like this bulb, right? So what are the major properties of this light? See here, it having the many wavelength. What it mean? What is mean by wavelength? Anyone?
Sir, it's the distance between two waves which are between two waves.
Yeah, okay, it's a periodic, it's okay. Wavelength, a fingerprint for any wave. Okay, a wave should having its own wavelength, like our names. Okay, now we can see what we can see here. We can see the multiple wavelengths, means that we can see the number of wavelengths coming from the incandescent light. And here we can observe that it is in the multi-directional. If you open like this bulb, what will happen? All waves will come from our bulb in all direction in 360. Means that around 270 we can see. Okay, it is incoherent. Incoherent means it has a different wavelength and different, okay, and less intensity, because it is a multiple directions and it will interfere with each wavelength and it will reduce its intensity. It won't, we can't see them in the long distance. Am I clear? Am I clear about the incandescent light?
Yes, sir.
Now we can see what is the important properties for the laser. What we can see here from this diagram, we can see the monochromatic waves. It is a monochromatic. Here what we can see, it is a monochromatic and it is a directional. So we can see only unidirectional, and it is coherent. Coherent means the phase difference between the two wavelengths is constant. Okay, and it having the very high intensity. Am I clear?
Yes, sir.
Am I clear? Am I clear here? Incandescent light and the laser, how we can distinguish? A layman can easily identify what is the difference between the laser and an incandescent light. It is clear to everyone?
Yes, sir.
I need response from you.
Yes, sir.
Okay, good. Now we can see what are the important properties we have to consider. What is mean by laser? Anyone? The abbreviation of the laser? What is the abbreviation of the laser? Anyone? We have 60 participants. What is a laser? You are using in torchlights, everything you are using now. We are playing with the laser. I think in 10th class itself, you have the lasers. +2 also. What is the abbreviation? Light amplification by stimulated emission and the radiation. This is the direct question. Light amplification by stimulated emission of radiation. Right? Am I clear? Everyone?
Yes, sir.
Yeah, now we will ask in the examination what is the laser, like that. But you should not write alone this sentence. What we have to write here? This is the first. You have to write 3 bulletin points. Light amplification by stimulated emission of radiation. Next, A device can produce a coherent beam of optical radiation by stimulating the electronic, ionic, or molecular transition to high energy levels. Clear? So here what we are doing, we are pumping the low level photons to the high level photons, or through the electronic or ionic or molecular transition to high level, and it come back and it will give the lasing action. It will be followed by the remaining slides. I am just giving the definition how we can write. So these things we have to write. We will ask in the examination, what is the laser? Laser means light amplification by stimulated emission of radiation, and a device can produce the coherent beam of optical radiation by the stimulation of electrons or ions molecular transitions, like that. And next, when they return to the low energy levels by stimulated emission, they emit the energy. That energy we call the laser. Like this you have to write. Okay, if anybody asks what is the laser, you have to say the what is the abbreviation and how it is happening, what is the pumping modes, how we are getting the energy from the lasing action. Okay, these 3 points are very important for an examination point of view. And if you any layman ask you, means you can say that easily how it is happening, lasing action, how you can distinguish the normal incandescent light and the laser. Okay, now you can see what are the history of the laser. Anybody knows here? The Charles Towns Nobel Prize he got the Nobel Prize in 1964. Arthur Schawel of the Bell Laboratories. These two scientists invented the laser, but initially they invented the instead of laser light, they invented the microwave. Okay, is this clear?
Yes, sir.
Okay.
Yes, sir.
So we should know who invented first. If any topic or any idea or any physical materials, we should know who invented, how they invented, what is the importance, how they struggle. Everything is very important while studying in the any subject. Don't study like a layman. Okay, you just go to the background. What is the history? Why it has arises? How we can apply? Then what modification we can do later? How we can implement or improve? Like that you have to think. Okay. Now you can see. So what are the important properties of the laser is directionality, a monochromatic and coherent and high intensity as compared to a normal light. Okay, these are the main important properties of the laser. Okay, with these properties we can differentiate the laser with respect to the normal light. Now you can see what is the monochromicity and what is the directional, what is the coherent. Coherent means phase in space and time, and these 3 properties of lasing actions are what can make the more hazardous. Why you can say hazardous as compared to the normal light? Anyone? Why lasers are hazards? Means it's not good for the humans, not good for our skin. Why? Anyone?
It has a higher intensity.
So higher intensity, nothing but high energy. So our skin or our eye won't bear that much energy, right? That's what it is hazard to the any living thing. Okay, with the low intensity we can do the miracles. We can use for the medical applications, we can use in the military applications, we can use in the so many applications we have with the lasers, right? Now, so what are the basic principles we should remember while talking about the laser? First one is stimulated or excitation. What it means, stimulated absorption or excitation? Anyone? Any idea? So if you want to start a laser, what we have to do? We have to initiate. We need some starting energy to start our lasing device, right? So we have to stimulate the photon to the ionic material or semiconducting material or a polymer or anything. So lasers will be any kind. It will be a solid state laser. It's a liquid liquid laser. It is a gas laser. Right? Anybody tell me any gas laser name? Very famous laser. Have you heard about helium neon laser? Anyone? Have you heard about the helium neon laser? A ruby laser? A semiconductor laser? Anyone? No?
No, sir. No, sir.
So it's a very well-known terms if you are talking about the laser. Lasers, we are having the gas lasers, we have the semiconducting lasers, we have the solid lasers. These are all depend upon the which application, what kind of the energy, where we have to apply. That depend upon the we can construct our own lasers. Okay. So here we have the stimulated absorption. What are the basic principle and what is the lifetime? How much time our photon can excite from the ground state to the excited state and how much time it will stay there. That is very important in laser. So how much more time it will stay, it will give that much intense energy. Okay. And it is a next one is the spontaneous emission. After staying in the excited state, it will spontaneously emit the photon and come back. Okay. Next, it is a metastable state, means that it will come back to the another state. We call the metastable state, where the photon will exist for more time as compared to the excited state. That we call the metastable state. And from there to it will come to the stimulated emission. Finally, it will give the lasing action. These are the things will happen in any laser. First, stimulated absorption, lifetime, spontaneous emission, metastable states, stimulated emission, and lasing actions. So these are the 6 things you have to remember for constructing the any laser, and we have to get the idea of what kind of the laser I have to prepare, what is the energy required to my application. That is very important by constructing the laser. Am I clear to everyone? So now we can see the individual topics. What is the stimulated absorption or excitation? What it means? See here, what we can see here. Here we can see the ground level to the excited state. Here you have to think that the laser nothing but ground level means there we have the electrons. Okay, electrons can absorb the energy in the form of the photon. Okay, that photon can excite it to the excited level. From electron, it will take the energy. How we can say here we have the energy. So with that energy, we can go to the higher state. Here, what we are taking the energy is electron. Electron taking the photon energy and it will remove from its the bound level and go to the excited state. Okay. Then it will stay over the excited state. Next, after some time, it will come back to its original state, which is called stimulated emission. Or sometimes it will stay in the metastable level and wait for some more time and come back to the its original state. So here, what are the things you have to remember? In ground state, we have the electrons. What is our energy we are giving is a photon. Photon nothing but it is a radiation. Am I clear? So now we can see how it is happening. Now I am giving the photon energy. My electron is moving ground level to the excited level continuously. So it is absorbing the photon, going up and down, and once again observing the photon coming, going up and down. So what will happen? It's going up and down. What will happen? This energy can be properly arranged and it will do the lasing action with respect to the photons. Now you can see the absorption, how it will happen. Now we are giving the photon, we have the electrons here, and we are giving the photon. What will happen? It is going to the excited state and stay at the higher energy state. Is it clear to everyone? See the slide. See for 1 minute. Check it. If you have any doubt here, you can ask me. See the slide. What we can see, we have the 2 energy levels. Okay. The atoms will be remain in the ground state unless some external energy, nothing but the photon, to stimulate our electrons to the excited state. After that, what will happen? I'm giving the energy to my electrons. What will happen? Some of the electron will excite from the ground state to the excited state. Okay, is this clear? This slide is clear?
Yes, sir.
Yes, sir.
Okay. Now here you can see. So what is the lifetime? The lifetime will be the 10⁻⁻8 seconds a maximum in excited state. So whether this time is high or low? Anyone? How much time an electron can stay in an excited level? What we can say here? It is a high time or low time? See the properly, 10⁻⁻8 seconds, nothing but 10 nanoseconds. So how much time human high can capture? Anyone? Any idea? What is the frame rate? Anybody knows? Frame rate? Now we are using the 120 Hz, 144 Hz speed in your mobiles. Huh? What is that frequency means? Hertz means, frequency means. Any idea whether anybody think about that one? Simply we are using some numbers and we are using. Now you are using the mobile. What is the refresh rate? 60 Hz, 90 Hz, 120 Hz. What is that importance? Any idea? Just think, okay, this is the very less time that can be stay in a excited state. Okay. Next, see here, what is the spontaneous emission? After going to the excited state, within 10 nanoseconds, it will come back to its ground state and it will give the what are the energy it has taken. So here we have to remember that how much energy it has to take in to the excited state and it come back to its original state and it release the not same energy of the photons. So because it has taken some energy to go to the higher energy level. Okay. So here we can see the what is three kinds of the processes are here. We call the fluorescence, phosphorescence. Anybody knows what is the fluorescence? Fluorescence, what is meant by fluorescence, phosphorescence? Any idea? We are seeing the fluorescence materials. We are using the radium for the fluorescence. How it is working with the low light? Any idea? Have you think about that one? How it is working in fluorescence mode? Why some radium lights and radium bulbs we have? How it is working with low light? Have you think? So you have to think. So what is happening? What is the mechanism here? We can see here it's exciting and caving. After that, what will happen here? Here you can see it is. Now you can see. There we have seen only one level. Here we can see this is the ground state level. We have in ground state also we have so many sub levels. That's no need, but you can understand it. So we have the molecular orbitals and electronic orbitals. The orbitals only the electrons will stay with that electron. Whoever the electrons stay along with the atomic orbital or molecular orbital that can excite it to the next orbital level. Okay. Now you can see from ground state to the excited level, it gone. And after that, it is coming back directly to its excited state itself. There we called it is called the fluorescence. After that, some of the photons will go to the metastable state, will stay for long time, and it will come back to its ground state. That we call the phosphorescence. Okay, this is the technical terms. So if you have any doubt, you can go through the Google, you can search in the Google, then you will get the all idea. Okay. Now the characteristics of the spontaneous emission. How we can characterize the spontaneous emission? So now we can see here in ground state, we don't have the any electrons will stay. Everything will excited to the its excited state. What will happen after that? It has the spontaneously emit the that electrons and give the our photons, whatever the energy it has used to excite. Okay. Now here we can see that it can be consider the atoms in the high energy level E2. It can decay the lower energy level by emitting the a photon. Right? What is the energy of the photon? The difference between the two energy levels. That is what how we can take the energy of the photon. What is the equation? Well, famous equation.
Hc upon m.
E is equal to h nu, right? Here we have the two energy states and we can differentiate two energy state and we can find out the what is the energy of the photon coming from the excited state to the ground level, right? Now we can see here the lifetime of excited state will be the 10⁻⁹ seconds, means that 1 nanosecond. Clear? Am I clear to everyone?
Yes, sir.
Yes, sir.
Okay, next we can see here it's coming one by one and come back to its original state and it will give the photon of energy. Now, what is meant by metastable state? I already showed in the previous figure, the metastable state is that after excited state, it come back to the metastable state and it will stay for some more time. It will give the phosphorescence, means that that energy of the photon will be very less. Okay. So this having the more lifetime. Now you can see there what is the stimulated emission. So I'm giving the photon, okay, it is exciting. After that, what will happen? It having the two photons can release with the same energy. Okay, if you want, I will go back, see the figure properly. You can understand. See for 1 minute what's happening here. I'm exciting, de-exciting, exciting, de-exciting. Okay. So once we started the lasing action, what will happen? Some of the photon will go up and come back, and some of the photons will go to the metastable state. The metastable state photons can come back, and once again it will pump the our electrons and will produce the more photons. So the lasing action will be continuous. We call it as a continuous laser. We have the metastable state, or we have the pulse laser. Pulse laser we have the continuous laser we have. Okay, depend upon the mechanism what we are using in the lasing action. Okay, now you can see what are the characteristics. So there are the metastable state. I already discussed with you. So it will stay up to 10⁻³ seconds, and atom, what will happen? Instant photon will come back and within the 10⁻³ seconds, and it will give the excited the once again it will start the process. So we are using only one photon and we will excite the electron and come back, and once again using the metastable state, we are de-exciting the electron once again and we are getting the more photons. So we are using the getting the more photon, more number of photon. What is happening? We are increasing the intensity, we are increasing the energy. Okay, we are increasing the energy. With the high energy, it will come, the laser will come from the our outlet. So that's what laser is working in this principle, using this principle only. Now you can see. So emitted photons are incoherent because in metastable to ground, it will come with the same wavelength and same phase. So it will be the coherent. Now you can see here. Let's see here. What is happening? We are giving the energy photon to the electron. That electron come back and it will release the two photons, and these two photons can be used once again to the electron. It will pump the more electrons and will give the more photons, and more energy will release. Okay. Now come to the what is the population inversion. So a state at which the substance has to be okay, energy are excited to the specific energy level. So what are the energy we need from the laser? We can alter. So here, where we are keeping our photons, that is our laser energy. Okay, that depend upon the what is the wavelength we are using. Generally, more number of the atoms present in the ground state than the excited state. Okay, normally we are before starting the lasing action, all atoms will be in the ground state. Once we switch on the laser, what will happen? One photon can interact with the ground state electron and it will heat up and come down and it will produce the more number of photons. The process will continue and we'll get the full lasing action. After that only we'll get the laser from the outlet. So the process of making more number of atoms in the excited state than the ground state, we call the population inversion. Means that what is the population in the ground state? We are minimizing the ground state population and we are increasing the excited state population of the electrons. Okay, I'm talking about the electrons. Sometimes we can say ions or sometimes we can say molecules. For our understanding, I'm taking electrons. Okay. Now like this, in ground state, it will be like this sleeping mode and in excited state like this. You already know all these things. Yeah, just insert the cartoon for your understanding. Okay. So here what is important is Boltzmann's equation. Anybody knows this, the Boltzmann's equation in your thermodynamics law? Thermodynamics. You have the thermodynamics, right, in +2? First law of thermodynamics, second law of thermodynamics. Have you studied or not?
Yes, sir.
Yes, sir.
No, thermodynamics also you did not study. It's okay, it's very simple. Here, what we are seeing, N1 and N2, N2 is nothing but the populated electrons, N1 is nothing but the ground stated electrons, and E2 is the excited energy, and E1 is the ground state energy. K is the Boltzmann's constant. Anybody knows about the Boltzmann constant? Anyone knows? Boltzmann's constant?
1.3 into 10 power
Minus 23.
minus 23.
Yes. Here, how we got the Boltzmann constant? This is the first law of thermodynamics. E is equal to kT. So energy is directly proportional to the temperature, right?
Yes, sir.
True or not? E is equal to kT. K is nothing but Boltzmann's constant. T is the temperature used to produce the energy. So here we can see that same formula we are using with respect to the number of electrons. Okay, N2 by N1 equal to exponential of minus of E2 minus E1 by KT. Am I clear? This expression is clear to everyone. The very simple expression. So what? Now you can
Rajesh,
see.
sorry
Yeah.
to disturb.
Okay, tell me, Suresh.
And since it is half an hour, we'll give
Okay.
you a poll to them with the 10 questions with whatever you said so far.
Okay.
Let them answer in 5 minutes, and probably you can continue.
Okay, we can do that one.
So students, you need to answer the questions now. So because all the basics he has done, and we're going to a little bit advanced. So these questions we want to know whether you could follow or not. So all of you need to answer these questions. So the poll will be starting now.
Shall I? Okay, can share. Okay.
Yeah.
Yes. Yeah, everyone, see the question.
You need to answer that. All 10 questions are there. Nobody is participated so far. I hope you are seeing the questions.
Everybody seeing the questions?
Yes, sir.
Yeah. Start answering. This is the interaction section.
Yeah, Rajesh, you can lead the guys' questions. You can probably.
Yeah. See the questions one by one. Are you able to scroll the question, students?
Yes, sir.
You need to answer the questions. I haven't seen any answers so far. So which means students, you are the passive ones. You're not there. And just to switch it on cam and went or what?
You know how to answer it, students?
Yes, sir.
Yeah, do it, man. Why waiting? It's a very simple. Okay, one answer. Good. Somebody answer something. Only 3. 64
Out of 60, only 3 people have actually answered.
or
Utilize this time as Sir is explaining. You can ask him questions if you are not sure of anything.
only 10 people answer till now. All Sixteen. At least half of people has to answer.
Please do it quick because we are running out of time and there are topics to be discussed. And remember that this will be taken also, as a part of continuous assessments, whether you are actively involving or not.
So we can understand from here who is seriously listening class or not. You can see the participation list also. Okay. So you should answer quickly. We'll wait for 1 more minute. That's all. After that, I will continue to the class.
Yeah, it's almost 6 minutes. Probably you can look at the answers, probably Rajesh, and then you can continue.
Okay, I will end the poll now.
Probably, yeah, okay. You want to end the poll and you reflect on questions? 45. 45 students.
Students shall end the poll or still you are answering?
Yeah, at 8 minutes, we will 30 seconds more, we will stop. Utilize 30 seconds more is there. If anybody wants to answer, you can answer. Then I'll quickly review the questions and then we'll continue. 15 more seconds. 5 seconds more. Right, we are ending. So 48 students actually answered. Let us review the questions. Question number 1, most of you actually answered correctly. Laser acronym, it is light amplification by stimulated emission of radiation. Still 4 people have confusion. They answered wrongly. So out of 48, 44 people said it is correct. Then if the electron excites from lower state to higher state, then that process is called, yeah, it is absorption, because it is going from lower energy to the higher energy, something it should absorb and go. So 16 people answered correctly. It is not spontaneous emission or stimulated emission, it is absorption. Laser has a high degree of all of the above. Yeah, still coherence 14 people answered, intensity 7, monochromatic 1, but 26 people answered correctly. It has all the properties: monochromacity, coherence, intensity, and a few more also which are not listed here. Then which of the following conditions is very essential for production of laser light? So spontaneous emission, stimulated emission, population inversion, all of the above 12 people. In the process of laser, all these processes are actually required. So all of the above is the answer. 12 people answered it. In conventional laser sources, so it has no coherence, which means the photons go at different directions. This is the correct answer. So different atoms emit photons in different directions. Whereas in laser, they have the coherence. So in spontaneous emission, question number 6, what happens? Atoms are initially in the excited state. No. Are you scrolling, Rajesh?
Yeah, I'm scrolling.
No, don't scroll. No.
6th question only, right?
Keep it there. Yeah. In spontaneous emission, what happens? It should emit spontaneously, which means the electron should be on the excited state. That is the primary condition. So atoms are initially in the excited state. That is true. And also, it is spontaneous, which means it doesn't need any external agency. So transitions are without any aid of external agency. Both are correct. So the correct answer would be both A and B. It's not simply A and B. Then 7th question. Sir actually asked so many times, but sad to see that still the lifetime of excited state is mentioned wrongly. Roughly only 30 people answered correctly. It is 10 power minus 8 seconds. Question number 8. In laser source, you actually have same phase and same direction. That is the answer for it, both A and B. ninth question. Which event is likely to take place when a photon of energy equal to the difference in energy between the two levels in a system? What will happen? When, which means that we are asking, you are supplying energy to the electron. What happens? That is the question in other way. So what happens? Electron takes the energy and it will go to the higher energy state. The process is called absorption. Then question number 10. Two photons will release in which process? I'm surprised to see that only one person wrote it correctly. It is stimulated emission. That is the heart for the production of the laser. You are supplying one photon and you are getting two. That way you are multiplying and finally you will get laser light. So that is stimulated emission. Right. You can continue, Rajesh.
Okay. Thank you, Suresh. Yeah, now you can some of them are understand somewhat clearly. Some of them have still have confusion. Okay, now with the question, I guess everybody got the clear picture about the lasing actions. What is the laser? What is the absorbance? What is the emission? What is the stimulated emission? What is the spontaneous emission? Right? This clear to everyone. Now we are going to the Boltzmann's equation. This is the next level for the how we can get the energy, how we can exactly know the what kind of the photons we are getting, what kind of the energy we need, how we can calculate. Okay, previously what we talked about the previous slides are just a basics and what are the mechanisms we need to produce the laser. So here we can see the quantitatively how much energy required and what kind of the photons are releasing and how many photons are releasing to produce the lasing action. Here we need the basic equation called the Boltzmann's equation. Here we can see that we have the N is the number of electrons of the energy level, E1 is the ground state, and N2 is the number of electrons in the excited state. Now we can see the N2 by N1 means number of electrons in the excited state by number of electrons in the ground state equal to the exponential of minus the difference between the two energy levels, E2 minus E1 by KT. So now we can see here, right? Now, for example, I am taking my temperature is T equal to 3000 Kelvin. The energy difference is 2 electrons. Anyone can calculate the value? N2 minus N1 will be there 4.4 into 10 raised to minus 4. What it mean? Anyone? The number mean? You know the K value. I have given the T value. E2 minus E1, you already know. Then, what is the N2 minus N1 equal to 4.4 into 10 raised to minus 4? What it mean? Any idea? Think. Just transfer the N1 to the this side, value side, and transfer this value to the N2 side. What we can see, we have the more population inversion at particular temperature, right? What will happen? 10 raised to minus 4 this side to come this side. It will be positive, right?
Yes, sir.
Okay. So like this, we have to calculate. The temperature is very high, 3000 Kelvin. Anybody tell me what is the temperature in degrees? How we can convert degree to the Kelvin? Any idea? One degree equal to how many Kelvins?
273.
473 or 273?
273.
273.
273, right? Now we can just subtract the 273 from here and we will get the how much degrees temperature we are using. Around 2800 degrees. That much temperature, we have this much of electrons in the excited state. Okay. Now we can see here The population inversion N2 is greater than N1. That means, okay. Now, next topic is what is the Einstein coefficients for the lasing actions. Here you have to understand very clearly what is the probability density, what is meant by probability of the finding the electrons or any photons. Anybody knows what is the probability means? What is meant by probability? Anyone?
Sir, what are the chances it may or may not be there?
Yes, good. So probability nothing but we are assuming that will be there. Probability of finding the any particle, any item there, that we are calculating the statistical mechanically. Now probability density means number of items can present at particular time or particular place. Okay. Now here we can see the energy level diagram. The probability of the stimulated absorption, this is the coefficient. Absorption coefficient will be the what is the density of the radiation used, and this is the spontaneous stimulated absorption. So stimulated means what it means? We are giving the energy to stimulate to the excited state. Spontaneous means without giving the energy, it is coming back. It is clear to everyone. It is clear.
Yes, sir.
Sir,
Now you can see the probability of the stimulated and spontaneous emission. So this is the coefficient from top to down. One is this is stimulated, okay, stimulated emission, and this is the spontaneous emission. These two coefficients. From these two coefficients, what we have to calculate? The density. What is the density of the radiation? We have to calculate. So now, without the any radiation, these two are equal. Number of electrons and absorption coefficient and emission coefficient will be equal with respect to their numbers. Now we can substitute these values here, and we have the equation like this, and find out the what is the rho nu value. Anyone? From these two equations, anyone can tell me what is the rho nu value? Calculate. Try it. How to calculate? Right? In terms of the, now you can see here, you can rearrange the equation. I want to find out the what is the density of the radiation. This is the density of the radiation. So this is the density of the radiation means we are including the what are the number of electrons in the excited state and ground state, how it is coming, what is the radiation is coming. From here we can say that what is the laser energy. This from this equation we can quantitatively calculate the density of the radiation, means energy of the radiation. Now using this equation, and we have the, we can erase from here to here. This we call the Planck's law. Anybody know what is the black body radiation? Have you heard about the quantum mechanics? This is the starting point for the quantum mechanics. Understand? What is the black body radiation? Anybody knows what is the perfect black body means? Anyone? What is meant by perfect black body? Any idea? Any idea? Why? Whether the light is a radiation or a consists of the number of particles? Tell me, what is the photon? How we got the light is a radiation or energy particles like that? How we got that dual nature of the light? Anyone? Any idea? What is the dual nature of the light means? Anyone tell me, light is a radiation or energy particles? Anyone?
Energy, sir. Energy.
Energy particles are radiation. What is the difference between the radiation and energy particles? So you have to go through the what is the duality, what is the light. Just go through the Google it. Next class we should understand what is the light. Before 19th century, everybody say that light is a radiation. It's not having any particles. It's just a wavelength. After the 19th centuries, okay, Planck introduced the black body radiation and find out it consists of a energy particles called quanta. The quanta of energy equal to h nu. So we can say that light behave like a radiation and the energy. Okay, what is the photoelectric effect? What it means? Photoelectric effect prove that light is consists of the energy particles. What is the interference? Interference shows that it is a radiation. So light having the two natures. One is the particle nature, next one is the radiation. Am I clear?
Yes, sir.
So go through the dual nature of the light. How we can identify the light? What is the before 19th century? What scientists think? After the 19th centuries, what scientists think about the light? It will give you a brief idea why we are talking. Here we are saying that light is a particle, consists of the particle, and light is a radiation like that. Okay, so many YouTube videos are there, and so much literature is there. You just go through it and get a good idea. Okay. So from here we can see that the energy density directly depend upon the frequency. What is the relation between the frequency and the wavelength? Anyone? What is the relation between the frequency and the wavelength?
The E is equal
Inversely
to
proportional to each other.
yes, they're proportional to each other.
Inversely proportional to each other. So we have the here frequency, then the wavelength, particular wavelength we can identify from this radiation, right? What is the energy of this radiation is equal to a particular wavelength. So it gives the only single wavelength radiation, and it has to follow this equation. What it means? B12 means what it is? Stimulated absorptions to the spontaneous stimulated emission, that should be equal. This is the first condition to produce the laser. Next, what we can see here, spontaneous emission to the stimulated emission, that equal to this value. Okay, this is the Einstein coefficient we call. These two conditions at any laser has to follow. Okay, am I clear to everyone?
Yes, sir.
Now we can see here the probability density. We have what are the condition? From this condition, they identify that what is the visible photon, what we are seeing lively, that having the energy of 1.1 electron to the 3.1 electron. How we can say this is the energy? Anyone? You know the equation, E is equal to h nu, right? I have the energy of 1.6 electron volt. What is my wavelength? Can I identify it or not?
Yes, sir. We can identify through E is equal
Yeah.
to hc upon lambda.
Yes, simple, right? Here, from that lambda, they identified what is the energy of the visible photon. So visible light, what is the range? What is the wavelength we have in visible region? We have the VIBGR. VIBGR having the different wavelengths, having the different colors, right? Different colors means different energies. The energy ranging from 1.6 electron volt to the 3.1 electron volt. Am I clear to everyone?
Yes, sir.
Now, so what is the energy? E is equal to KT we have, right? In the room temperature, we have the 23, we will take the 23 as the 23 degrees as the room temperature, right? Okay, 273 plus 27, right? Equal to 300 Kelvin. With that energy, we have the 0.025 electron volts. Am I clear? So that energy is readily available in our surroundings. But that energy is not sufficient the electron to exit from the ground level to the excited state. So for that one, we need some external energy to pump the electron from low energy state to the higher energy state. Am I clear? What is the room temperature? With the room temperature, what is the energy we have? This is a very important question in competitive exams. 0.025 electron volts. How I got? We know the Boltzmann constant and we know the what is the temperature, room temperature. We will get in joules. The joules, how we can convert into electron volts? 1 joule equal to anyone? 1 joule is equal to 1.6 into 10 to minus 19 electron volts, right? Just divide with the electron volts. So you should remember that also. So stimulated emission dominates slowly when h nu by kT very, very less than 1. For microwaves, it is very less value. Okay. So this is the condition for the lasing. The population inversion electrons or any ions should be more than the ground state. Then only we can see the lasing action. Okay. From this, I can conclude my class. If you have any doubt, you can ask me now. Now 12 o'clock. I will share the questionnaire to your Google Classroom. You have to answer and you have to upload your assignment before November 1st. Am I clear to everyone?
Yes,
Okay.
Yes, sir.
Yeah, you can ask me any questions. If you don't have questions, I can conclude now. Everyone? Yes, you will get the notes. I will share the total slides to you. Yeah, this derivation, sometimes we may ask, we will ask what is the Einstein coefficients. So you have to use these equations. Yeah, you will get it. Engineering physics notes. Okay. Yeah, thank you everyone to attend the class. Suresh, are you there?
Yeah.
You want to speak anything? You can.
No, nothing. I think we are done.
Yeah. Thank you everyone. We are
Thank you, sir.
stopping now.
Thank you, sir.
Thank you, sir.